The 6th of April, 1943. Major Paul Pappy Gunn stood beside a heavily modified North American B-25 Mitchell bomber at Townsville Airfield in Australia, watching Army Air Forces engineers shake their heads at his radical design changes. The aircraft bristled with 8 forward-firing .50 caliber machine guns, a 75mm cannon where the bombardier compartment used to be, and structural reinforcements that added 2,000 pounds to its empty weight. Standard procedure called for medium bombers to attack from altitude using conventional bombing techniques. Gunn's modifications were designed for something unprecedented: low-level ship, killing attacks against the Imperial Japanese Navy. The experts said it would never work. 3 weeks later, his modified B-25 started sending Japanese warships to the bottom of the Pacific. The mathematics of naval attack aviation were unforgiving. Japanese destroyers and cruisers carried multiple 25mm and 40mm anti-aircraft guns designed specifically to engage low-flying aircraft. A standard destroyer mounted roughly 12 automatic cannons with overlapping fields of fire, creating defensive zones that extended 3,000 yards in all directions. Medium bombers attacking from conventional altitudes could avoid most defensive fire, but their bombing accuracy against moving ships was less than 8%. Low-level attacks offered 90% hit probability but exposed aircraft to concentrated anti-aircraft fire for approximately 45 seconds during approach and attack runs. At 250 knots airspeed, every second of exposure increased crew casualty probability by 15%. Gunn's modifications were designed to compress engagement time from 45 seconds to 12 seconds, while maximizing destructive capability against naval targets. Flight test engineer Captain Robert Chen examined Gunn's prototype at Townsville. The aircraft looked like nothing in any military manual. 8.50 caliber Browning machine guns were mounted in the nose section, replacing the standard bombardier position. A 75mm M4 cannon, salvaged from a damaged Sherman tank, occupied the lower fuselage where bomb bay doors normally mounted. Additional armor plating protected critical systems. The modifications increased weight from 21,000 pounds to 23,000 pounds, reduced maximum altitude by 3,000 feet, and decreased range by 180 miles. But the firepower concentration was unprecedented. Standard B-25s carried defensive armament totaling 6 machine guns. Gunn's modification mounted 14 guns plus the 75mm cannon. Total firepower exceeded most heavy cruisers. Chen questioned the structural integrity of Gunn's modifications. The 75mm cannon generated 18,000 pounds of recoil force when fired. The B-25's airframe was designed to handle bomb loads, not artillery pieces. The 8-nose-mounted machine guns created similar problems. Concentrated fire from all weapons would generate vibrations that could affect flight controls. No one had tested these modifications under combat conditions. Can you imagine flying an aircraft that might disintegrate when you pulled the trigger? But Gunn faced tactical problems that conventional solutions couldn't address. Japanese naval forces controlled shipping lanes throughout the Southwest Pacific. Their destroyer and cruiser squadrons provided escort for transport convoys carrying troops and supplies to forward positions. Standard high-altitude bombing attacks achieved minimal success against maneuvering warships. Japanese captains had developed evasive tactics that reduced bombing effectiveness to approximately 3% hit rates. Even direct hits from 500-pound bombs often failed to sink destroyers due to compartmentalization and damage control procedures. Gunn needed weapons that could guarantee ship kills with single attacks. His modifications were designed to achieve that objective. At 0847 hours on the 29th of April, 1943, Gunn conducted the first test flight of his modified B-25. Pilot Major Frank Harrison occupied the left seat. Co-pilot Lieutenant Mike Torres handled secondary systems. The aircraft lifted off from Townsville's 6,000-foot runway after a ground roll of 4,200 feet, 800 feet longer than standard B-25 takeoff distance. Climb rate was reduced to 480 feet per minute compared to normal 750 feet per minute. Maximum altitude reached 18,500 feet, 4,000 feet below standard service ceiling. But the aircraft remained stable and responsive, despite the weight increase and structural modifications. The weapons test occurred at 10:34 hours over water 40 miles northeast of Townsville. Harrison descended to 100 feet above sea level and established a firing run against a target barge anchored offshore. At 800 yards range, he opened fire with all 8 nose-mounted machine guns. The concentration of fire was devastating. Tracers converged on the target in a stream of destruction that lasted 6 seconds and expended 400 rounds. The barge disintegrated under the impact of .50 caliber bullets striking at 2,800 feet per second. But the aircraft vibration during firing exceeded all predictions. Harrison struggled to maintain level flight as the gun mounts shook the entire forward fuselage. At 600 yards range, Harrison fired the 75mm cannon. The recoil was immediate and violent. The entire aircraft nose pitched up 15 degrees despite full forward elevator pressure. The shell struck the water 200 yards short of target due to trajectory disruption from aircraft motion. Harrison needed 3 more attempts to achieve accurate fire with the artillery piece. Each shot required recovery from severe pitch displacement and recalibration of aim point. The cannon was devastating when it hit, but difficult to employ accurately during flight. Gunn's modifications worked, but they demanded exceptional pilot skill and physical strength. Ground testing revealed additional problems with Gunn's design. The 8 machine guns consumed ammunition at 6,000 rounds per minute combined rate. Standard ammunition load was 2,400 rounds total, sufficient for 24 seconds of sustained fire. The 75mm cannon carried 20 rounds maximum due to weight restrictions. Gunn had created a powerful but limited endurance weapons system. Japanese intelligence became aware of Gunn's modifications through radio intercepts and aerial reconnaissance. Imperial Navy headquarters issued warnings to destroyer and cruiser commanders about modified American medium bombers conducting low-level attacks. Japanese anti-aircraft tactics emphasized maximum rate of fire during approach phases when aircraft were most vulnerable. On May 14, 1943, Harrison's modified B-25 conducted its first combat mission against Japanese naval forces. Intelligence reports indicated a destroyer squadron operating 120 miles northeast of Port Moresby. 3 Fubuki-class destroyers escorting transport vessels. Harrison's mission was tactical reconnaissance and weapons testing. Not decisive engagement, but reconnaissance revealed target opportunities that demanded immediate action. The Japanese formation was proceeding at 18 knots in line formation, perfect geometry for Gunn's weapon system. Harrison approached from the southwest at 150 feet altitude, below Japanese radar coverage. The 3 destroyers first detected the B-25 at approximately 4,000 yards range when lookouts spotted the aircraft silhouette against cloud formations. Standard Japanese defensive procedure called for immediate evasive maneuvers and maximum rate of fire from all anti-aircraft positions. The destroyers executed sharp turns to port and starboard, presenting narrow profiles to reduce target area. All 25mm and 40mm guns opened fire simultaneously. Tracers filled the air between the ships and the approaching bomber. Harrison flew directly through the defensive fire. At 1,200 yards range, Harrison opened fire with his 8 nose-mounted machine guns. The concentration of fire was unlike anything Japanese naval personnel had experienced. Previous American bomber attacks involved scattered defensive fire from multiple gun positions. Harrison's modification created focused destruction that overwhelmed individual target sections. His tracers converged on the lead destroyer's bridge structure with precision that defensive fire couldn't match. The ship's command personnel were killed within 4 seconds of engagement. But Harrison's primary target was the anti-aircraft positions. Harrison's tactical approach exploited weaknesses in Japanese defensive doctrine that no previous attack had revealed. Standard anti-aircraft tactics assumed attacking aircraft would employ conventional approaches, high-altitude bombing or torpedo runs from extended range. Japanese gunners were trained to track targets across predictable flight paths and lead their fire accordingly. Harrison's low-level, high-speed approach compressed engagement time to 8 seconds and eliminated predictable maneuvering. Japanese gunners couldn't adjust their fire fast enough to track the rapidly changing target. The psychological impact of concentrated machine gun fire proved as important as physical damage. Japanese naval doctrine emphasized disciplined fire control and coordinated defensive action. Harrison's attack created chaos that disrupted established procedures. Anti-aircraft gun crews abandoned their positions to seek cover when .50 caliber bullets began destroying equipment and personnel around them. The few gunners who maintained their positions found their weapons ineffective against Harrison's approach speed and attack angle. Standard defensive fire patterns were designed for aircraft approaching at conventional altitudes and speeds. Harrison's modifications created tactical conditions that Japanese training hadn't anticipated. At 600 yards range, Harrison fired his 75mm cannon at the lead destroyer's waterline. The high-velocity armor-piercing shell penetrated the ship's hull below the forward gun mount, detonated inside the magazine compartment, and triggered secondary explosions that destroyed the entire forward section. The Fubuki-class destroyer broke in half and sank in less than 3 minutes. Harrison had achieved something unprecedented: a single-pass kill against a major Japanese warship using modified bomber armament. But Harrison's attack run wasn't complete. His ammunition load remained sufficient for engagement against the second destroyer. He executed a sharp climbing turn to port, gaining 400 feet of altitude for improved attack geometry, then rolled into a diving approach against the second ship. Japanese defensive fire intensified as gunners realized the effectiveness of the American modifications. Multiple hits struck Harrison's aircraft, damaging the port engine and severing hydraulic lines. But the structural modifications that engineers had questioned provided crucial protection. The reinforced fuselage absorbed battle damage that would have downed a standard B-25. Harrison's second attack run demonstrated the tactical principles that would define anti-ship warfare for the remainder of the Pacific Campaign. Speed and surprise could overcome superior defensive firepower if attacking aircraft concentrated maximum destruction in minimum time. Harrison's 8 machine guns and 75mm cannon delivered more explosive force in 12 seconds than conventional bomber attacks achieved in multiple passes. His modifications proved that technological innovation combined with tactical adaptation could reshape the balance between offense and defense in naval air warfare. The second destroyer suffered catastrophic damage from Harrison's attack, but remained afloat. Multiple .50 caliber hits had destroyed most anti-aircraft positions and killed roughly half the crew, but the ship's main structure remained intact. Harrison's 75mm shell had struck the superstructure instead of the waterline, causing extensive damage without breaching the hull. The destroyer was combat ineffective but salvageable. Japanese damage control procedures enabled the ship to maintain steerage and begin limping toward friendly ports. Harrison faced a critical decision during his climbing turn after the second attack. His ammunition load was nearly exhausted, 200 machine gun rounds and 3 cannon shells remaining. The third Japanese destroyer maintained full defensive capability and had maneuvered to maximum range to avoid Harrison's approach. Standard procedure called for immediate withdrawal when ammunition was low and aircraft damage was significant. But Harrison recognized tactical opportunity. The damaged destroyer was attempting to escape, presenting a perfect target for his remaining firepower. He chose engagement over withdrawal. The final attack run occurred at 12:48 hours. Harrison approached the damaged destroyer from its starboard beam, exploiting the ship's reduced defensive capability. Most anti-aircraft guns on that side had been destroyed during his previous pass. The remaining gun crews were focused on damage control rather than defensive fire. Harrison closed to 400 yards before opening fire with his remaining machine gun ammunition. His tracers walked across the destroyer's deck, destroying equipment and personnel with systematic precision. At 300 yards, he fired his final 75mm shells. The first cannon shell struck the destroyer's engine compartment, penetrating the main boiler and triggering steam explosions that disabled propulsion. The second shell hit the ammunition storage area, detonating charges that blew a 20-foot hole in the ship's port side. The third shell missed due to aircraft vibration from previous impacts. But 2 direct hits were sufficient. The destroyer listed heavily to port, lost power, and began settling by the stern. Japanese crew members abandoned ship 8 minutes after Harrison's final attack. The vessel sank at 13:04 hours, 16 minutes after first contact. Harrison's modified B-25 returned to base with significant battle damage, but all crew members alive. Post-flight inspection revealed 14 bullet holes in the fuselage, damaged port engine, severed hydraulic lines, and structural stress cracks near the gun mounts. But Gunn's reinforcements had held. The modifications that engineers had questioned proved capable of surviving sustained combat stress. More importantly, Harrison had demonstrated tactical effectiveness that exceeded all projections. 2 Japanese destroyers sunk, 1 damaged, in a single 22-minute engagement. No American casualties. Intelligence analysis of Harrison's mission results revealed implications that extended far beyond individual tactical success. Japanese radio intercepts indicated widespread concern about American bomber modifications throughout the Imperial Navy. Destroyer and cruiser commanders requested additional anti-aircraft armament and modified defensive procedures. Naval aviation units received orders to provide fighter escort for all surface formations. Harrison's single mission had triggered defensive reactions that diverted Japanese resources from offensive operations to protective measures. But Gunn's modifications faced institutional resistance within the Army Air Forces. Standard procurement procedures prohibited unauthorized aircraft modifications. Gunn had installed weapons and equipment without official approval, using salvaged parts and field expedient techniques that violated engineering protocols. His success against Japanese naval forces was undeniable, but his methods challenged established military bureaucracy. Army Air Forces headquarters ordered Gunn to cease unauthorized modifications and return his aircraft to standard configuration. Gunn refused. His combat results demonstrated tactical effectiveness that conventional procedures couldn't match. 2 destroyers sunk versus typical bomber mission results of no confirmed kills. Resource efficiency was exceptional. 1 aircraft, 1 crew, 22 minutes of flight time. Decisive tactical victory. Standard bombing missions required squadron strength formations, fighter escorts, and multiple attack passes to achieve comparable results. Gunn's modifications enabled single aircraft to accomplish missions that previously demanded extensive resource commitment. The tactical mathematics were indisputable. The debate over Gunn's modifications reached General Douglas MacArthur, Southwest Pacific Area Commander, who personally reviewed Harrison's after-action report and intelligence analysis of Japanese reactions. MacArthur recognized strategic implications that bureaucratic procedures had overlooked. Japanese naval forces controlled critical shipping lanes. Conventional bombing attacks had achieved minimal success against maneuvering warships. Gunn's modifications offered tactical capabilities that could influence the entire Pacific campaign. MacArthur authorized continuation of the modification program. Despite Army Air Force's objections, production of modified B-25s began at Townsville in June 1943. Gunn supervised installation of weapon systems on 24 aircraft assigned to the 42nd Bombardment Squadron. Standardized installation procedures were developed based on Harrison's combat experience. Gun mount vibration was reduced through improved bracing techniques. Training programs for modified B-25 crews emphasized low-level attack techniques and precision gunnery. Pilots learned to manage aircraft control during sustained gun firing. The training was dangerous. 2 aircraft were lost during practice missions. When pilots lost control during simulated combat maneuvers, Japanese countermeasures evolved rapidly in response to modified B-25 attacks. Destroyer and cruiser formations began operating with fighter cover when possible. Anti-aircraft gun positions were reinforced with additional armor protection. Evasive maneuvering procedures were revised to counter low-level attacks. Most significantly, Japanese naval aviation received orders to hunt for modified American bombers before they could reach shipping targets. The Imperial Navy had recognized that Gunn's modifications represented strategic threat that demanded comprehensive response. The first major engagement between modified B-25s and prepared Japanese defenses occurred on the 17th of August, 1943. 6 of Gunn's aircraft attacked a cruiser squadron northwest of Rabaul. 4 Mogami-class heavy cruisers escorted by 8 destroyers and 16 Zero fighters. The Japanese force represented approximately 40,000 tons of warships protected by over 200 anti-aircraft guns. Standard tactical analysis suggested the modified bombers faced impossible odds. The engagement lasted 34 minutes. Japanese fighters reached attack position first, diving from altitude advantage. Standard Zero tactics emphasized speed and maneuverability advantages against bomber formations, but Gunn's modifications had transformed defensive capabilities. Each B-25 now carried 14 machine guns, creating defensive firepower density that made close-range attacks extremely dangerous. When 16 Zeros attacked 6 bombers, they encountered defensive fire equivalent to a heavy cruiser. 3 Zero fighters were confirmed destroyed during the approach phase. 2 others damaged. The modified B-25s lost no aircraft, but suffered battle damage that reduced ammunition supplies. 8:14:39 hours. Harrison's formation reached attack position against the Japanese cruiser squadron. 4 Mogami-class heavy cruisers, each displacing 13,000 tons and mounting extensive anti-aircraft armament. 8 destroyers provided additional defensive fire. Harrison's attack plan exploited Japanese defensive weaknesses that conventional tactics had never revealed. His aircraft approached at medium altitude, 800 feet, too low for effective high altitude defensive fire but too high for low level guns to achieve optimal tracking. All 6 modified B-25s approached the cruiser formation simultaneously from different vectors, creating multiple threats that divided Japanese defensive fire. Harrison's attack against the lead cruiser demonstrated the effectiveness of Gunn's modifications. His 8 machine guns concentrated fire on the ship's superstructure, while his 75 mm cannon achieved 3 direct hits that penetrated the cruiser's armor. Secondary explosions began within 30 seconds. The ship was dead in the water, with uncontrollable fires within 4 minutes. 4 Japanese cruisers engaged, 2 sunk, 1 heavily damaged, 1 lightly damaged. 8 destroyers engaged, 3 sunk, 2 damaged. 16 Zero fighters engaged, 5 confirmed, destroyed, 4 damaged. American losses: 0 aircraft shot down, 3 aircraft with significant battle damage, 2 crew members wounded. The exchange ratios exceeded every projection for bomber operations against defended naval targets. Japanese post-action analysis revealed psychological impacts that extended beyond physical damage to ships and aircraft. The effectiveness of American modifications had exceeded Japanese expectations and demonstrated tactical innovation that challenged established naval aviation doctrine. Imperial Navy commanders requested immediate development of countermeasures and defensive procedures specifically designed to handle modified bomber attacks. The single engagement had triggered institutional response throughout Japanese naval aviation. Intelligence intercepts revealed that Japanese concerns about modified American bombers were influencing strategic decisions about naval deployment and operational procedures. Destroyer and cruiser squadrons began operating closer to shore, based fighter cover whenever possible. Long-range patrol missions were reduced to minimize exposure to bomber attacks. Most significantly, Japanese naval aviation resources were diverted from offensive operations to defensive missions protecting surface ships. Harrison's tactical success was generating strategic effects throughout the Pacific theater. But Gunn's modification program faced logistical challenges that threatened its continuation. The 75mm cannons were salvaged from damaged Sherman tanks, and replacement parts were difficult to obtain. Machine gun installations required specialized mounting hardware that wasn't available through standard supply channels. Ammunition for modified weapons systems competed with requirements for conventional aircraft. Most critically, qualified maintenance personnel were limited to the small team at Townsville. Expanding the program would require resources that the Army Air Forces was reluctant to provide. The solution came from an unexpected source. Navy aviation units operating from Henderson Field on Guadalcanal had observed the effectiveness of Harrison's attacks and requested similar modifications for their PBJ-1 aircraft, the Navy version of the B-25 Mitchell. Navy procurement procedures were more flexible than Army regulations, and Navy logistics could provide parts and ammunition through different supply channels. Joint Army-Navy cooperation enabled expansion of the modification program beyond the limitations of single-service bureaucracy. By October 1943, roughly 60 modified B-25s were operating throughout the Southwest Pacific, equally divided between Army Air Forces and Navy squadrons. Standardized modification procedures reduced installation time to 120 man-hours per aircraft. Improved gun mount designs eliminated vibration problems that had plagued earlier installations. Enhanced ammunition storage increased firing duration to 45 seconds of sustained fire. The 75mm cannon received improved recoil systems that reduced aircraft displacement and increased accuracy. Gunn's field expedient modifications had evolved into systematic weapons systems. Training programs for modified B-25 crews had expanded to include advanced tactics developed through combat experience. Low-level approach techniques minimized exposure to defensive fire while maximizing attack effectiveness. Formation procedures enabled multiple aircraft to coordinate attacks against large target formations. Ammunition management techniques conserved firepower for critical engagement phases. Damage assessment procedures helped crews determine when targets were sufficiently destroyed to justify disengagement. Combat experience had created tactical doctrine that no peacetime training could have developed. Japanese countermeasures had evolved as well. Fighter cover for naval formations became standard procedure whenever possible. Anti-aircraft gun positions received improved armor protection and ammunition supplies. Evasive maneuvering procedures were revised based on analysis of American attack patterns. Most significantly, Japanese naval aviation began developing dedicated anti-bomber fighters equipped with heavy cannon and armor specifically designed to engage modified B-25s. The arms race between offense and defense was accelerating throughout 1943. The largest engagement involving modified B-25s occurred on the 15th of December, 1943, when 18 aircraft from 3 squadrons coordinated attacks against a Japanese task force northwest of Truk. The target formation included 2 battleships, 4 heavy cruisers, 6 destroyers, and a light aircraft carrier, with approximately 40 fighter aircraft. The attack developed over 4 hours as individual squadrons approached from different directions. The first attack wave sank the Japanese carrier by concentrating fire on aircraft and fuel systems during flight operations. The second wave engaged the battleships, achieving mission kills through superstructure damage that disabled fire control systems. The final wave attacked cruisers and destroyers under maximum defensive conditions. American losses were 4 B-25s destroyed, 8 crew members killed, 12 wounded. Japanese losses included 1 carrier sunk, 2 battleships damaged, 1 cruiser damaged, 2 destroyers damaged. Post-action analysis revealed strategic implications that extended beyond immediate tactical results. Japanese naval operations were constrained by the threat of modified bomber attacks. Major warships required fighter cover when operating within 300 miles of American air bases. Naval aviation resources were increasingly devoted to defensive missions rather than offensive operations. But American losses demonstrated limitations that strategic planning couldn't ignore. Modified B-25s were effective against surprise targets, but vulnerable to concentrated defensive fire from alert opponents. The solution emerged from technological development rather than tactical innovation. New aircraft types entering service in 1944 offered capabilities that made B-25 modifications obsolete. The Douglas, a -26 Invader, provided superior speed and armament. The Republic P-47 Thunderbolt could carry bombs while retaining fighter performance. Most significantly, carrier-based aviation was achieving sufficient strength to conduct major anti-ship operations without requiring land-based bomber support. By June 1944, production of modified B-25s had ceased, and existing aircraft were gradually returned to standard configuration. But the tactical lessons learned through combat experience influenced anti-ship doctrine throughout the remainder of the war and into the jet age. Gunn himself transferred to engineering duties in early 1944, working on various aircraft modifications throughout the Pacific theater. Harrison continued flying modified B-25s until the program ended, achieving 17 confirmed ship kills. Their innovations were studied by military aviation schools worldwide and incorporated into post-war aircraft development. What tactical lessons emerge from the modified B-25 program? First, that innovative adaptation of existing equipment can provide crucial capabilities when formal development cannot meet operational requirements quickly enough. Second, that technological advantage is temporary and must be exploited rapidly before enemy countermeasures reduce effectiveness. Third, that tactical success depends on understanding both friendly capabilities and enemy limitations. Most importantly, Gunn's modifications demonstrated that individual initiative and creative problem solving could influence strategic outcomes when institutional procedures proved inadequate. The modified B-25 program proved that innovation often emerges from operational necessity rather than theoretical development, and that field experience frequently generates solutions that formal engineering cannot anticipate. Combat effectiveness ultimately depends on the integration of technology, tactics, training, and leadership. Gunn's modifications provided technology, but success required tactical innovation, specialized training, and leadership that encouraged experimentation. The program worked because all elements functioned together effectively. The story of modified B-25s demonstrates that individual initiative can reshape warfare when creative minds address operational problems with innovative solutions. Gunn didn't wait for formal approval or institutional support. He identified tactical requirements that existing equipment couldn't meet and developed modifications that provided necessary capabilities. The 6th of April, 1943, they said the modified B-25 would never work, that field-expedient weapons installations couldn't match formal development programs, that medium bombers couldn't engage heavily defended naval targets successfully. Major Paul Gunn proved them wrong by sending Japanese warships to the bottom of the Pacific with aircraft that bureaucrats insisted were impossible. The experts who questioned Gunn's modifications understood engineering principles and procurement procedures, but they missed the crucial factor that determined success: the willingness of creative individuals to challenge assumptions and develop unorthodox solutions when circumstances demanded capabilities that didn't exist. Can you imagine being told your innovative solution would never work, then proving its effectiveness by achieving results that conventional methods couldn't match? Gunn faced that challenge and responded by building aircraft that changed anti-ship warfare forever. His story demonstrates that individual determination combined with technical competence can overcome institutional resistance when operational necessity demands innovative solutions. If this account of innovation triumphing over conventional wisdom moves you, hit that subscribe button and turn on notifications. We're preserving the stories of individuals who prove that creative adaptation can reshape warfare when existing methods prove inadequate. Drop a comment and tell us, what would you have done when faced with impossible tactical requirements and inadequate equipment? Thanks for watching. We'll see you in the next story of innovation born from operational necessity.